hello to you all. Some of you will have realised by now that my expertise does not lie in large open pit mining. So I offer these comments and suggestions to you with great respect to this gathering of experts in this area. If I were giving this presentation some years ago, we might have been talking about the difficulty of collating, gathering, communicating large amounts of data across the mining area. We might also have been talking about measuring the location and tracking the location of equipment precisely, use of GPS precisely, which has had a lot of problems over the years. But nowadays, those systems have come to the fore, and they're reaching areas of practical development that they are being now installed in mines in a practical way. For example, the large open pit at KCGM is using advanced technology to precisely locate equipment and communicate that back in a very reliable way with wide bandwidth. Also, the communication nodes that reside on equipment pass information from one to another. They constitute ad hoc communication networks, and the whole system operating together. This technology is now being applied. One or two mines, perhaps several mines, maybe not throughout the industry, but it's there in a practical sense now. And that communication technology is being developed in areas other than mining, but applied. So, I'm from the Queensland Centre of Advanced Technologies in Brisbane, and you can see in the top right-hand corner, Brisbane in the background, our laboratory in the foreground. I should add, though, the communication nodes and networks have come so far, we even have cows now with tags around their necks, and these tags monitor where the cows go throughout the day. Ad hoc networks are formed, virtual fences are formed, and the cows are discouraged from crossing over the fence line. So even the primary industries and the agricultural sector are using this technology. Who knows, they're probably also capable of tracking the amount of greenhouse gases they produce, no doubt. Both speakers this morning mentioned some of the drivers for advanced technology and why we need to improve the industry and adapt new technology. Population growth, just putting some data behind some of those suggestions. It's well known out there. Australian minerals production is increasing somewhat exponentially over a long period of time, while at the same time the grade of our ore that we're mining is decreasing. Waste rock is also increasing. And on top of that, the net increase of workers to Australia's workforce is on a gradual decline over years. In fact, somewhere around 2027, maybe we'll start hitting a zero net increase in population growth. According to the Minerals Council of Australia, that somewhere between 2005 and 2015, we'll actually need a net increase in by 50% in the workforce for the mining industry, equating to about 70,000 people in all. Safety is another one of those drivers. You can see plotted up on the top left-hand corner there, the lost time injuries is gradually decreasing over time. On the right-hand side, you can see the fatalities decreasing over time as well. Fewer numbers, obviously, of those, which explains the high variation in the rate from year to year. Internationally, though, Australia is doing reasonably well. You can see roughly on par with Canada in a global sense. On the other hand, these trends are slowly reaching a plateau, and maybe that it'll be very difficult to move beyond that and to improve safety even further without some significant change in the way that we mine. At the same time, we'll have new challenges. Automated trucks will be introduced over time. Currently operating 5 trucks, Komatsu trucks, the modular mining guidance system in Antofagasta in northern Chile. So as discussions are underway and as we think about applying those in Australia, these will bring with it greater safety challenges that we need to respond to. Fortunately, though, over time, legislation has changed and we've moved towards a risk-managed regulatory environment. This means that we will take lots of care over the introduction of these systems and think very carefully about how we can isolate manual from automated traffic in these situations. We need to make sure, and I have to be very careful how I say this, but we need to make sure that the introduction of remote control in underground mining doesn't result in injuries and fatalities when we do get around to installing those systems. With remote control of loaders, for example, this was actually introduced to improve the safety, to stop people getting injured if they took an LHD into an open stope in unsupported ground. We told people to stay away from them. We even suggested perhaps that people stand on a pile of dirt or on a barricade or behind a wall to protect themselves. But these were really procedural type controls, and people were injured and killed, unfortunately, in that introduction. Since that time, though, teleoperation has improved the safety of those activities, and we also now have fail-safe barricading that prevents people getting close. So drivers and responses, what are we doing? Well, we're doing a lot of research to try and address these issues, from improving exploration technology, advanced communication technology is being developed and applied, remote and automated operation is being introduced, and also control over mining processes and equipment via the internet, which originally wasn't designed for this type of activity. Some of the things, though, for the future, I mentioned safety, and maybe what we need now to do is introduce some form of real-time safety management, which includes being responsive to a lot of the sensors and the information that's out there, and then applying rule engines to guide us in safety management. One of the other areas that we'll see coming through, in fact it's happening now, is the introduction of other skill sets from other sectors of the industry, and these include perhaps psychology, social sciences, and if we're going to remote control equipment well beyond line of sight, perhaps thousands of kilometres away or around the globe through the internet, then we'll need to address some of the other issues that will be brought to the fore in that process. For example, operators can't see, feel, touch, and the psychologists will help us figure out what types of sensors, what types of input, what types of feedback will be required so that operators can handle that challenge. Continuous selective mining. Well, this is a question, and we'll come to that a little further on. And of course, the outcomes will be to address some of those drivers that we talked about. Just looking at the automation response, there have been recent surge in the desire for automation among the mining industry, and however the present focus is to automate and remote control existing operations. This is a type of retrofit. This is now being applied to LHDs, draglines, loaders, trucks, dozers, graders, all sorts of pieces of heavy equipment. Drills, of course, as well, and systems are being developed around the world to improve remote control of drilling, sensing while drilling, blast drilling, and also exploration drilling. This brings some benefits: smooth and programmed operation of equipment. If something is automated, semi-automated, or operator-assisted, then you can program the operating envelope for the equipment, and it will, short of something going drastically wrong, stay within that operating envelope and reduce maintenance on tyres and equipment damage and all the rest of those sorts of things. Of course, that'll improve safety as well. But retrofitting has some limits. Mining systems are not designed for automated operation. Manual automated people need to be separated from these operations, and the protection is at this stage, unless you can protect the whole area, isolate an area, then there are no fail-safe systems to keep operators separate from automated machines. So the full benefit of automation won't be realised, I think, until we can actually automate the complete cycle and integrate a number of these technologies. We talked about protecting people from safety. A lot of devices out there are really used to guide operators and to remind operators that perhaps there's an issue about to come about. Maybe two pieces of equipment are moving close together. A number of technologies are out there that will constantly search for and detect when they find something. This includes radar, scanning lasers, RF beacons and the like. But they have a fundamental problem in fail-safeness, because fail-safeness in a practical factory-type automation requires a signal to be received constantly and checked constantly, and when that signal is lost, then an alarm is raised. some of these other types of technologies, which are probably really the only practical thing to do at the moment, don't fall into that purely fail-safe category. There is a desire out there in the industry, and Rio Tinto's desire has been published. They are looking for applying advanced technologies to remote control as much of their operation as they can. There's no secret now that's out in the news across the industry. Many of these operations can now be controlled by the web, and we've seen examples of that. So what we are seeing now is a greater increase in contribution from a large range of skill sets. Bob Adam mentioned to me this morning when he was talking to a colleague of his about in-pit crushing. Apparently the colleague said, gee, open-pit mining's starting to get like longwall operation. And I said, well, strange you should mention that. Recently, over the last couple of years now, automation of longwall operation has been very successful, installed and run for 18 months at one mine at Beltana in New South Wales, now being installed in 2 Queensland mines in various stages of development. I used this, I want to show you this, because firstly it's a very complex environment, very difficult. The electronics, all of the technology, not only does it have to work, it has to be intrinsically safe or enclosed in special housings. But this is an example of a remote control mining method via the internet, provided the mine operators allow researchers to operate the thing from a remote site. And I can assure you they probably won't do that, but it's certainly capable of that type of operation. It's also an example of geologically guided mining machines, something else we're looking at applying now in the hard rock area. So it's got integrated geology and spatial sensors to provide an intelligent mining system. I'm not sure if you can see it. It's a little bit of a dark image, but that's the way it is underground in a coal mine. But you can see how intense, how crowded and how hazardous underground coal mining can be. You saw a flash of the shearer on one side. You can see the chocks above moving and pushing the shearer and the chain conveyor forward, advancing it through the mine, and while at the same time people are actually walking over those chocks. What you'll see on some of the other following animations, you'll see a mimic panel, a model of the shearer and the chocks. On the top left-hand side, you'll also see another mimic of an elevation view of the shearer with a lot of sensors on there indicating the state of the machine. And you'll also see a plan view diagrammatically over here, which shows the various chocks and their location and pressures in the chocks. One thing to note here is that while this does look like an animation and a model, the model is actually moving synchronously with the real sensors that are located underground in the coal mine. And this is the big difference between, this is the great advance now in the way that we can automate mining equipment. So the operator can get multiple types of views. You can watch the operations happening from anywhere in the world via internet communication technology. As I mentioned before, the machine is actually moving synchronously. You can see the colours of the powered supports there, coloured in terms of their pressure. And if you look along the row, you can see how the whole long wall is actually undulating following the seam. You can also look at drill core, drill holes, and other geophysical data superimposed on the mining operation. Another view, he can look at the shearer, as I mentioned before. He can see the chocks, how they're advancing. He can expand those views and look in great detail about what the operation is doing. Should also add, though, that while this technology is now applied, we haven't actually removed people from the longwall face. Some of the geologically guided sensors that can be introduced, we've looked at how you track the whole mining operation in the coal seam. This is a view of a thermal infrared camera watching the shearer. You can see the shearer cutters rotating here, cutting the coal away. Can you see that? Yeah. And you can see the bright spots really respond to slightly higher temperatures. Now, in some parts of the coal, you can see that the temperature stays there and persists over a period of time. And this probably, obviously this results from a zone of higher friction. That zone of higher friction obviously relates to the type of material being cut. Maybe it's higher clay content, maybe it's rock, maybe it's sandstone. It's unlikely to be coal. So this provides the operator with a view that isn't normally seen with human eyes. One comment I often get from people when we talk about remote control is that the person's no longer there, and the eyes are the best sensors the world has, apart from the other. And that's quite true, but along the same lines, we can develop sensors that look beyond the electromagnetic range that the eyes are sensitive to. We can look in the ultraviolet and the infrared and see things that the eyes can't see. This is an example of looking at a marker bed, clay marker bed in the coal seam. Cameras can track that seam, and they can use that piece of information to guide the whole longwall operation to make sure that it stays within the seam. So those are examples of some advanced remote control and the use of geology to guide mining machines. What about hard rock cutting? Wouldn't it be nice if we could cut hard rock to 100 to 60 MPa type rock strength using cutting methods? Well, a number of researchers are working on this problem, and over the full course of time, no doubt we'll see rock cutters being used in open cut mining, and that might open up opportunities that we haven't yet thought about for selective mining, for example. A number of developments around the world. There's a Smartcut technology being looked at by CSIRO, oscillating disc cutter by CRC Mining, activated disc, and I must admit I haven't checked whether they're still doing this by the CSIRO in South Africa. And of course the Minimol program now put in abeyance from the Placidone group. Quick shot here of some Smartcut technology actually cutting basalt. So we can see, at least in a very rigid, fixed laboratory environment, that cutting hard rock is emerging as a possibility. Now, if that were to happen, then we can have machines, certainly in the iron ore area, perhaps a planing machine that can take selective mining, plane, cut rock, produce sizes that perhaps bypass the ag mills and the sag mills, do a number of the processing operations while actually mining. That also then allows you to sort ore while it's happening and minimise the carryback of waste. This is an example where you might have a truck following a planing machine, and I know these are now being trialled and looked at in the iron ore industry, and starting to produce a farming type operation in the mining area. We'll be able to sense the changing geology ahead of the machine, also after the machine. We can control cutters, we can sort on the conveyor belt, for example, if we need to, and produce a continuous mining operation. Some of the sensors that we might need, we've looked at hyperspectral scanning, and this type of technology is now being rolled out in core logging examples. The hyperspectral electromagnetic reflectance from terrains. Each type of mineral has a different spectrum, and you can use that to colour a mining face sensitive to the mineral content, and then of course overlay that perhaps onto a photogrammetry image of the same material. A bunch of other sensors are being looked at, quadrupole resonance techniques, especially for copper, laser-induced breakdown spectroscopy. These are all remote sensor technologies that might in the future be applied to mining machines. Terahertz radar, currently been developed for security. It sees through clothes, can identify and tell the difference between cotton and silk, for example, and find contraband on people coming in through immigration. We're going to be looking at how that can be used in mining for downholes and also for open cut areas. I've produced these slides here with the permission, and I'm very grateful to Professor Alan Bligh of the SMI University of Queensland, who has proposed this concept of integrating a whole range of technologies into a real-time risk assessment process. Includes ground probe and CSIRO vision, a whole bunch of survey type applications. And one of the issues is that all of these are developed in isolation. They're all optimised in isolation, and perhaps it's now time to try and integrate all of these things into a risk management algorithm. One of those algorithms may be a new system that's come on board and developed again in the coal industry called Nexus. This is a real-time risk management system where a bunch of sensors are used to inform the software about conditions underground, and there's a rule engine or a program in there that uses those sensors to assess what the likelihood of, in this case, explosions might be. And these are all plotted on likelihood and consequence type graph. Obviously up here in red is where you need to avoid, and the situation at any place selected moves across this plot and leaves a trail, leaves a history, so in one glance you can see whether the whole process is moving to an unsafe or risky domain. The software and the backbone and the architecture makes this also available for managing systems such as geotechnical risk in a high wall area. So, just looking very quickly at some of the other automated processes that are happening in the open cut domain. These are emerging, these are still in a research area, but over the fullness of time we might see them being employed in open cut mining. Dragline assist. Okay, I know draglines are not used in metalliferous mining, but every now and again mining consultants talk about the concepts, or mining companies, internal advisors, talk about the prospect perhaps of using draglines in an open cut metalliferous mine. This technology is now automated. It has been trialled, not fully adopted yet in the coal industry, but it comes with the capability of mapping the terrain as you mine and keeping good track of the whole process. Trials indicate that the automation system is almost as efficient as operators, but it is stable in its performance throughout the shift. Another technology being developed is to operate shovels, automate the dig process, make sure that the digging is occurring with inside the appropriate envelope for the machine. You can scan the bucket, sense that it's full, and you can look at the profile trajectory here. You can see as the bucket's being crowded and loaded, it's lifted up, it swings, comes back and dumps. This technology has now been proven in a small scale setup as you can see there on the screen. Once again, automated loading is also possible, and traffic management in a close environment is also possible. So you can see that not only can the shovel be loaded, but it can also swing and dump and identify a truck at the same time. You can see here a laser scan of the truck. The truck's scanned, the load can be assessed, and it can be decided where the next bucket is dropped. Over on this side you can see a truck approaching. This is like an aircraft traffic management situation. You can see the shovel over here, and you can see the truck being tracked and locating throughout the cycle. This means that the close and fine detail of the scheduling and precise positioning of trucks with respect to shovels can also happen in the same time. Looking at something different, strangely enough, some of my colleagues are looking at, in collaboration with other researchers, how to mine on the moon. And I mentioned before that the internet produces lots of good data transfer, but it's not designed for automation. And one of the reasons it's not designed for automation is that it exhibits a lot of variable delays, and that can be very difficult for remote controlling operations. Well, there's no more variable delay than communication up to the moon or Mars, so there's a trial research program to see how mining equipment can be remote controlled, operator assisted, with long and variable delays. So there's a NASA project which is looking at operating large mining equipment, and in this case it was operated from the US with a test mining equipment in Brisbane, and that was operating very successfully. So, in conclusion, where are we going? We're going to see a lot more introduction of equipment retrofitted in terms of automation. Once again, what's being looked at the moment is retrofitted technology like this in isolation, not as a systems approach, not as a systems view. And I think greater benefits will be obtained when we start to combine all of these individual operations into a proper system. Research now into positioning and of mining equipment, scheduling, dispatching is well under control by at least two major suppliers of this type of technology. That's now falling into the domain that you can buy these things off the shelf. And the research effort probably is more of an industrial research effort to adapt particular technologies into a mining operation and perhaps to change the way that the operation is otherwise undertaken. Many of the component technologies are available, and the communications networks will continue to rapidly improve over time, and we don't really need to worry too much about that. The other industry sectors are doing a pretty good job of developing that type of technology. What they're not looking at, though, is the particular issues of mining equipment, how we develop new mining equipment, how we look at new mining processes. This is still within the domain of the mining industry, and no one else is going to undertake that research apart from the industry itself. We're going to see a lot more contribution of skill sets other than electrical, mechatronic, mechanical, mining engineering, and these will come from the psychology and social type sciences. This is now being applied, for example, in telemedicine, where surgeons can, for example, live in the Blue Mountains and undertake operations on a patient based in Sydney. These technologies are now available. How they get into the mining industry is worthy of a great deal of effort in terms of research. And this will make remote control and automation of distant remote mining equipment a lot easier and a lot more achievable. So I offer those suggestions as someone who is not an expert in open cut mining, and open the floor to questions. I think is that the program, Bob? Thank you.
Jock, I wonder if you could just give me your thoughts on whether you think the mining industry is spending enough money on research into these new types of technologies.
Yeah, thanks, Nick. And I didn't ask him to ask that question, but look, perhaps embarrassingly, I can't quote you the figure that companies spend on research, and often they're a bit hard to believe anyway, because a lot of companies do research, and sometimes they don't even realise they're actually doing research. So you know, I think probably, obviously, you'd expect me as a researcher to say no, not enough money is being spent, but I might just add that there is a difficult threshold which perhaps we in Australia are not very good at crossing compared with other countries, and this threshold might be at a point of taking an idea which has no track record, which has no demonstration sites, taking it over that threshold into mining trials. And I know of a number of projects now that perhaps are a little bit way out, a little bit controversial, a little bit far-fetched, and it's very difficult to cross the threshold of faith to gain funding at that point. So maybe what we're missing out on is that zone of research that requires more speculative type funding. Once something is demonstrated and shows some potential for improving the industry, then mining companies in the large, especially during these boom times, find it more easy to justify spending research in that application phase.
A question to you there. Our observation is that in many cases there's a little bit of tension between the research that's done and the mining companies, in that the mining companies themselves would like to see the existing technology integrated, and the researchers would like to research new technology. I wonder if you could give me some comments on that and how you see that tension there.
Yeah,
if I might be so direct.
Yeah, no, sure. There's nothing wrong with tension. And I think you'll find tension and balance in just about every area of human endeavour. So that tension is fine, and it depends on the activities of the researchers, whether they're right out at the sharp bleeding edge of development, and some research organisations are designed to be in that zone, and that's what they're looking for and looking ahead. There are some research activities way down more in the applied areas which have a much easier to see line of sight to application. So I think I admit, yes, there is some tension there, but also add that perhaps there needs to be that tension. People who can afford the resources to look way ahead. We call it the Horizon 2. I'm not quite sure what the timeline on Horizon 2 or what Horizon 3 makes, but right out on the bleeding edge, some researchers need to be. But in order to make sure that they have a stream of income as well from the industry, and to help governments understand that they're doing research that is recognised by the industry as valuable, they also need to get funding in the shorter term as well as a demonstration. So researchers need a broad spectrum from the more applied right out to the bleeding edge, and all zones in between. So more applied research, for example, helps researchers to stay in touch with the industry as well, and to get their feet on the ground and their hands dirty in mining operations. Is that answering your question? Yes, we do need to be at the bleeding edge.
Yes,
that has the danger of leaving the industry behind a little bit. You can't be too far out so that you lose ties, at least with the more adventurous of mining operations. So they need to be out there enough. It's sometimes difficult to judge how far out that is. A very innovative manufacturer of mining equipment in Australia once told me, and I totally agree, that he likes to be maybe 2 or 3 years ahead of where the industry is. Beyond that, he can't afford to be. And because it takes 2 or 3 years to develop new technologies that he is looking at, and that's a comfortable position for him.
Thank you.
Yep.
Jock, if I might ask a question just to promote a bit of discussion. You've spoken, most of what you spoke about was existing technologies, adaptive approaches. If you had a crystal ball, what do you think the new technologies when you give this presentation in 3 to 6 years' time at the next large open pit mining conference, what will be the new technologies that you'll be talking about then?
Yes, well, as I said, I wasn't talking about positioning and data communication between vehicles now, because maybe 5 or 6 years ago it might have been, but not now. I think we'll be talking about the first mine maybe that tried operation of an actual mining process based in I don't know. I don't think anyone will mind me say up in the Hamersley from Perth. So we might be talking about some of the early results of that, and we might find that the operator based in Perth has got a pretty fancy control interface where he can feel some of the controls. He can feel the interaction between the machine and the ground. He can see the grade of the ore that's being mined, and he can place it in the appropriate place so that it's taken to the appropriate stockpile for processing. Whether we'll see rock cutting, I'm not quite sure. I think there's still a way to go in practical hard rock cutting, but certainly the mining trials are beginning. I understand the oscillating disc cutter is being trialled in South Africa. Joy have made a prototype of that equipment. Maybe we might see some early trials of that being done as well. Will we see maintenance? I mean, we're not talking about here removing people totally from a mining operation. People still need to be in place for various things. One of the big downsides of automation is that it doesn't react very well to disturbances in normal operations. So we'll still need people on site who can take care of some of the unexpected events. Obviously, you'll need people on site who can set equipment up and also to service the equipment as well. So perhaps the maintainers might be in higher proportion on site as well. We'll see a greater proportion of people trained in engineering and scientific skills as part of the processes. So operators will move gradually from being on the machines, operating every moment of the machine, every movement of the machine, to operators who are now supervisors of the mining process.
There was a question over here. Laura, if you would. Could you just give us your name and affiliation?
Peter Williams at Newmont. I was wondering if you see a lot more technology going into drill bit science, so we collect better metallurgical information and more information about in-ground, because with lowering grades and higher strips, one of the problems that the industry faces is capitalization of new projects.
Yep.
And lack of data.
Yeah, absolutely. And I know there are a number of research programs around the world looking at drilling technologies, and we've certainly had feedback from mining companies that this is a critical area of importance. We have the Amira drilling roadmap, for example, and we're also addressing in our little neck of research, addressing some of those issues of that Amira roadmap. So yes, I think we will need, we will see development of better drilling technologies. That's essential. I know some of the drilling manufacturers are looking at that. Well, I'm going to mention companies anyway. I probably shouldn't. I'm from the government, but anyway, we know that, and you will all know that Atlas Copco have taken a push towards automation of drilling, both underground and surface operations. And the bits that are being researched now, not only improving the way that holes are being drilled, the progress, the wear rates, higher productivity in the actual drilling, but also trying to extract information from the hole while the drilling is occurring. And we also have our own part of research there, which has come from a position, we call it the sweet spot drilling control. It's come from a position of improving the way that the drill is controlled, but we've discovered now that that can provide feedback to the type of rock that's actually being drilled. I know that CRC Mining are looking at measurement while drilling in the iron ore area, and they're running a program and apparently doing quite well, getting some successful information back off the drill bit to identify some of the geotechnical, what would you call it, the rock properties as they're drilling. So we've got examples now where prototypes are being trialled. Another one of the drilling manufacturers, which I won't name because I'm not sure if it's made public, is also looking at resonant drilling, driving the drill in terms of its impact. I mentioned terahertz radar before. We're keenly interested in that. Getting technology from other industry sectors is really useful. It's happening in communication. We now see terahertz radar being used in the security area. We've observed that that can distinguish properties of the material that it's looking at. So we're saying, aha, maybe we can also discern mineral properties in the same way. And so we'll be looking at that. You've got hyperspectral technology being developed. The trick is to try and make these sensors and instruments that are otherwise very sensitive and delicate and applied to other domains. The trick is to make them robust and rugged for operating behind a drill rig, behind a drill bit. One of the other things being looked at, there are a lot of sensors now that relate to geomagnetic properties, but there's no good in using those when the drill string is made from steel. So we're also looking at making fibre composite segments of the drill string that can house such instruments and sit fairly close behind a drill bit. And the state government in Queensland is sponsoring some of that work to develop some of the high-tech fibre composite material for that type of application. That'll also perhaps include drill strings, flexible drill strings that you can wrap up on a large reel. So, yep, lots of research being done all around the world in terms of improved drilling, and very difficult task, but I'm sure we'll get there.
Okay, thank you. All right, we'll take one more. Just behind you there, Laura.
Jock, we know that truck automation is coming along pretty well. You showed some examples there of shovel automation. What sort of time frame do you feel that we're looking at before the shovels are essentially automated?
I think that probably comes back to an earlier question we had. The first question up the back is that industry funding for this research, and I think the time frame will be directly governed by the amount of funding that research gets to take it from an experimental trial operation into a real application in a mining area. There is a project being undertaken now by ACARP to apply this type of technology in collaboration between the CSIRO and the CRC Mining. That's happening now to apply this technology, trial it in a real mining machine in the coal area. So let's say, it's crystal ball stuff. Perhaps over a year or two we might see that successful, and there's a commercial partner which has been identified, needs to take that on, re-engineer it for commercial rollout. Maybe that's another few years, so 5 to 10 years maybe. Yep.
Right, thank you very much, Jock.
Thank you.